Alright, hi guys, today I'm going to be doing a video on standard deviation. Okay? And I'll explain what that actually means in a minute, but the example that I'm going to use is two footballs named Steve and Roy. And what I want to be working out is their average goals scored per game and the standard deviation of that. Now, what standard deviation is, in this case, is on average how much do they deviate from their average value, from their mean value. So, standard deviation is a measure of consistency. The lower the standard deviation, the higher the consistency, because they, on average, deviate less from their mean. And so I'll be comparing this over 30 games played of football. So I'm going to introduce the equation. Now, it may not quite make sense in a minute, but I hope we will explain this later. Right, this symbol means standard deviation of x equals the square root of sigma, which means sum. So the sum of the fx squareds minus the sum of the fx's, sum of the f, lots of x bar, x bar squared, over sum of the f minus 1. Sorry for saying that. Now, out of this, these things here will become apparent later, but I'm going to explain briefly what x bar means. X bar is another way of saying the mean, the average. So actually, average goals will be x bar when we work that out. Oops. And the standard deviation is, of course, standard deviation of x. So x bar is sum of the fx over sum of the f. Now, these three things, sum of the fx squareds, sum of the fx, and sum of the f's, will become apparent later, and they're based on our data set. So now, time to set up our dataset table. So you'll probably be given this during the exam for the actual question that you're given. I'm just going to set mine up here. So frequency of Steve and frequency of Roy. And this little table here, probably will be given, but I'll write it out. 0, 1, 2, 3, 4. So in each of the games they played, they either scored 0, 1, 2, 3, or 4 goals. And so from the data set, we've got that Steve scored no goals 12 times out of 30 games. He scored 1 goal 8 times, 2 goals 8 times, 3 goals once, and 4 goals once. On the contrary, Roy scored no goals 4 times, 1 goal 21 times, and 2 goals 5 times, and then 0 for the rest of them. So if you sum these up, these will equal 30 over the 30 games. Okay, now just for the next one, I'm just going to go on to a new piece of paper. Okay. So we're now going to write this table out slightly differently. So in our first column, we're going to have x. Then we're going to have Steve, and then Roy. Just draw a double line to indicate the big difference here. Okay. So now here we're going to be given. We're going to need to work out the. We're going to need to work out the f's, the fx, and the fx squared for each person. So x equals 0, 1, 2, 3, 4. And in this case, x is the number of goals scored per game. Hence 0, 1, 2, 3, 4, 0, 1, 2, 3, 4. Okay. So, just divide this little table up a bit more. Okay. Sorry for the unneatness. I'm not very good at drawing straight lines, so I didn't take art. Right, so we know from our data here that we can put in he scored 0 goals 12 times. Frequency, how often? 1 goal 8 times, 2 goals 8 times, 3 goals 1 time, and 4 goals 1 time. For Steve, and for Roy, it's 4, 21, 5, 0, and 0. Okay. So now we need to work out the frequency x, which is just frequency times by x. So 0 times 12, 0, 1 times 8, 8, 2 times 8, 16, 3 times 1, 3, 4 times 1, 4. Same here, 0, 4 times 0, because the x column's here, 0, 21 times 1, 21, 5 times 2, 10, 3 times 0, 0, 4 times 0, also 0. Okay. And last column, this is fx squared. So you square x, and you times it by the frequency. So 0 squared is 0, times 12 is 0, 1 squared is 1, times 1 equals, sorry, times 8 equals 8. So it's slightly to get different. 2 squared is 4, time, sorry, 2 squared times 4, sorry, 2 squared is 4, times 8 is 32, 3 squared is 9, times 1 is 9, 4 squared is 16, times 1 is 16. This column, 0 squared is 0, times 4 equals 0, 1 squared is 1, times 21 equals 21, 2 squared is 4, times 5 equals 20, 3 squared is 9, times 0 is 0, 4 squared is 16, times 0 equals 0. Okay, now the next thing we can do, we've got one last column here, in row, sorry. This is sigma, this is sum. So this here is the sum of the frequency. Now frequency is how often they scored each of these things, and that is actually how many games played, and as we know, we played 30 games. So that is 30 in both cases. If you add it up, it's 30. Sum of the fx, this is actually how many goals they scored in total, which in this case, if you add these up, 31. If you add these up, what's 31? And this is the sum of the x squareds. Slightly different. In this case, this is 65 and 41. Do this with a calculator. So now, I'm just going to split this into 2. I'm going to do Roy and, sorry, the other round, Steve, and then over here we're going to do Roy. Okay? And so the sum of the the things we need to work out for this equation here is we need the sum of the fx squared, sum of the f's, and the sum of the fx. We have all of these things. The sum of the fx squareds, in this case, is 65, and the sum of the fx equals 31, and the sum of the f's equals 30. First thing you want to work out is the average goals. So x bar equals sum of the fx over sum of the f. So we know that x bar equals 31 over 30. So x bar, in fact, equals 1.033 to 3 decimal places. And that is the average goals scored by Steve per game. Now to work out his standard deviation. So, from this equation, we know that the standard deviation of x is the root of sum of the fx squared, so that's 65. Sorry, right here. Try to write it like this. Sorry. So it's the 65 minus 30 lots of 1.033, because that's x bar, squared, divided by sum of the frequency minus 1, so that's divided by 29. This comes out to be 1.066. Do that on a calculator. And Roy, okay, so that is actually the standard deviation of Steve. So on average, he scores 1.033 goals. but then also on average he deviates by 1.066 from his average of 1.033. Basically what it means here. So, in Roy's case, x bar, just skip all this bit because it's written out, x bar is equal to the sum of the fx, which in his case is 31, and he's played 30 games. So actually, the x bar of Roy is also 1.033, which means on average they scored the same number of goals per game. However, this is where it gets different. The standard deviation in this case is 41, not 65, 41, minus 30 lots of 1.033 squared over 29. In this case, it means standard deviation is 0.556, 3 decimal places. Now, what this means in terms of that, these are your answers. Okay, so you've actually got the answers. You have the average goals scored for each player, and the standard deviation of goals for each player. Okay. Now, the last thing that you need to do, you might need to do, is compare. As in, what does this actually mean? This means on average, they scored the same number of goals, but because Roy's standard deviation was lower, he was more consistent in his goal scoring. So, he was a more consistent player overall, even though both players scored the same number of goals. And that is what standard deviation is for, working out how consistent a set of data is. In this case, happened to be footballer, so it's how consistent the footballer is. But this works for different heights of plants. If a gardener was growing different plants, standard deviation would be how consistent one person's plants were compared to another person's plants. It's all about comparing consistencies, how consistent a set of data was. So I hope this gave good explanation onto what standard deviation is. And one last time, that is the formula for standard deviation. So if you're given this as your set of data looks like that in an exam, write it out like this. You can. Makes everything a lot easier. And then sum all the columns. And then use these values in the equation to get your answers. And so I hope this was helpful in understanding standard deviation. Thank you for listening, and I hope you learned something. Bye.